Hello, this is Chaitanya. Today I will be explaining how to download Vivado and how to create a sample project in Vivado. Vivado is basically used to program your FPGAs. To program your FPGA, first you need to download Vivado. You can download Vivado from the xilinx.com. You can go to downloads and here are the versions which you need. Basically, you can download any version and the version which I am using is 2022.2. You can download the latest one from here from the xilinx.com website. After downloading this, it downloads an installer. Basically need a 60 GB of storage free space on your disk to install Vivado. After you're done with installation, open Vivado. It takes a few seconds of time. Let it open. Vivado is can be downloaded on any computer. It's compatible Linux and on Windows also. This is the GUI you will be looking after downloading the Vivado and installing the Vivado. There are many options here. There are some example projects which are present by default which will be present by default when you install Vivado. You can open a project if you have already created a project. Now let's see how to create a project. Let's go to create project. Click on next. You could select the project name and the project directory. You can select any directory you want. You can create the directory anywhere you want. Click on next. Next. If you have any design files already present with you, you can add them directly or even you can write them in the Vivado app in the software. Click on next. If you have any constraints file, you could directly add them or also you could add them in the software. And here you need to select your board. Right now I am working with a Pink ZU board. If your board is not visible here, it can be downloaded. The board file can be downloaded from the documentation of the board. I downloaded the Ping Setu board. Similarly, you could find your respective board from the documentation or the website of the Ping board. Click on next. Click on finish. And this is how the Vivado GUI looks like. Now you need to create a design source. Click on design source and click on add. You need to create a design source. Click on next. Click on create file. Give some name. Let's say test one or anything, any name of your wish. Create file. Cancel. Sorry. Finish. Now, if you have any input ports, you could add it directly from here, or also you could add it in the Verilog. Yes, here. Let's say I'm creating a very small Verilog module, which will be one, which where my output will be one if my input is one. That's it. Say input a comma. But here you need to write your Verilog code. You can write any code of your wish. I'm writing a small Verilog code. This is my code. Now we need to simulate, synthesis and implement this onto the FPGA. Simulation step is used to run a simulation of your design to verify its functionality before hardware implementation. You could do run behavioral simulation. You need to save the Verilog code. During this step, during the simulation step, Vivado simulates the behavior of the design using test bench and simulation models to check for errors, timing issues, and logical correctness. Our code doesn't have any test bench, so this is like this. A small waveform window will be open. We could see that we did not add any test bench. That's why the values of A and B are Z right now. If your design source has any test bench, you could add it in the simulation sources. Go to simulation sources and you could press add and add your test bench or even create your own test bench in the Vivado GUI. Now next run synthesis. Let's run synthesis. Synthesis in Vivado is used to convert your high level RTL design into a gate level netlist. This is what will be implemented onto your FPGA. After the synthesis step is finished, you will see a small pop-up box like this. There are three options. You could directly run the implementation, that is the next step, or you can open the synthesized design, or also you could see the reports of the synthesis. Now I will show you how the synthesized design will be. Let's click on open the synthesized design. This is how the synthesizer design will be. You could also view the schematic of your design here. This is the Verilog code which I written. This is how the design for the Verilog code that will be implemented on the FPGA look like. And before you go to the implementation step, you need to define the constraints. That is, what is the input and output ports be on that FPGA. Suppose I want my input port to be a switch on my FPGA. For that, we need to go through the documentation of the FPGA. Right now, I'm using a Pink ZU board. The documentation will be available in the pink.io website. You just need to go to internet and press Pink your board name and its documentation. You could go down, scroll. Yes, here we could see what the switch one represents and what its constraint number package pin is. This is the pink board I am using it right now. I am the designing in such a way that when I turn on this switch, this LED 0 should also turn on. So for that, in the constraints file in the FPGA, I will take the package pin of this switch and represent it as an input, and take the package pin of this LED 0 and represent it as an output. So whenever my input in becomes 1, the output also will become 1, which will lead to turning on this LED. Let's go to Vivado, and for this input, and also for the input standard, we need to set it to LVCMOS 18. This board can take. That is standard for that board. It will vary on board to board. My input package pin can be seen from the documentation. For switch 0, it is AA12. I will write it here. AA, that is input. And my output, I want to turn on LED 0. The package pin for LED 0 is B5. I will write B5 here. So my constraints are defined. Now you need to save this constraints file. Let's say, let's give a name to it, constraints. Okay. After you finish writing this constraints file, you need to run the synthesis again. Okay. Let the synthesis run for this. Here, after the synthesis is done, there will be a small pop-up box. We already saw the open synthesized design. Now let's directly go to run implementation step. Okay. The implementation step in Vivado is the process where the synthesizer design is mapped to the specific resources of the target FPGA. The design which you created will be implemented onto the FPGA using this implementation step. Let the implementation run. After the implementation step is done, a small pop-up box will be open. There also will be having three options. One is opening the implemented design, One is the generate bitstream step, which will be the next step after the implementation step, and another one is a view report step. We could directly go to the generate bitstream step. The generate bitstream step in Vivado is the final process that creates the configuration file for the FPGA. This step creates a bitstream which will be given to the FPGA to program in such a the way we wrote the code. So this generate bitstream is the one which helps the FPGA to configure the configurable logic blocks and lookup tables on the FPGA. And this bitstream is uploaded onto the FPGA using an USB to B cable, which will be connected to your computer and the FPGA board which we are using. After the implement generate bitstream step is done, you can open the hardware manager. After opening the hardware manager, you click on open target. It will be visible here. If it's not, you can also see the open target step here. Open target. Press on auto connect. It automatically detects the FPGA board which is connected to the USB cable of your computer. It opened the FPGA board which is connected. Now you right click on it and you can see the program device option. This will load the bitstream onto the FPGA. Once you click the program device, then the bitstream will be programmed onto the FPGA. Here you can see this is the FPGA I programmed. According to my design, when I turn on the switch 0, the LED 0 should turn on, and this is happening exactly the way we decided to happen. And when I turn off the switch 0, the LED 0 should off. That means the FPGA is working the way we decided to intended it to do. That's it. That's how we program an FPGA. There are many other ways to upload the bitstream. We can also upload the bitstream using the processing system which is present on the PIN ZU board. Thank you.